Here we have a problem on finding derivative. So here we have a function that is y equals to e to the x power over ln x, and we have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Okay, in the given function, we have variable in both numerator and denominator. Whenever I want to find derivative of a function which contains variable in both numerator and denominator, I have to use coefficient rule. What is coefficient rule? Okay, consider the function which is in the form of u over v. So where both u and v are variables, that is both the numerator and denominator contain variable. So I want to find derivative of this function. So what should I do? I have to use coefficient rule. What is coefficient rule? So I have to square the denominator. So here the denominator is v. So first we have to square the denominator, that should be taken over here, and the same denominator v should be taken at the top. And now we have to get the derivative of the numerator u, that is u prime. Now we have to take negative and keep the numerator u as it is and get the derivative of the denominator v, that is v prime. So this is coefficient rule. So we use coefficient rule to get derivative of a function which contains variable in both numerator and denominator. Okay, so in our problem also, in our function also we have variable in both numerator and denominator. So we can use the coefficient rule over here. Okay, so we have to find dy over dx, that is we have to do derivative with respect to x. Okay, on the left side, when I find derivative of this y with respect to x, what do I get? I get dy over dx. Okay, on the right side, I have to use coefficient rule. That is, I have to square the denominator ln x. Then I'll be getting ln x the whole square. And now the same ln x should be taken at the top. And now I have to find the derivative of this numerator e to the x power. So we can write e to the x power prime negative. Now we have to keep u, that is the numerator, as it is, and get the derivative of the denominator, that is ln x prime. Okay, so ln x times the derivative of e to the x power with respect to x is just e to the x power negative e to the x power. The derivative of ln x with respect to x is just 1 over x over ln x the whole square. Okay, here in numerator, so both of them are multiples of e to the x power, because both the terms in numerator contain e to the x power. So e to the x power can be factored out. If I factor e to the x power out, I have ln x left in the first term and 1 over x left in the second term. So over ln x the whole square. Okay, now I have to simplify this stuff over here. So let's assume that ln x is an integer and this is a fraction. So here we have a subtraction of an integer and a fraction. Whenever we have a subtraction of an integer and a fraction, so what we need to do is we have to multiply the integer part by the denominator of the fraction. So once I'm done with this multiplication, I can take the denominator x as a common denominator. Okay, first let's multiply this ln x by x. X times ln x will be, one second, let me, e to the x power. When I multiply this ln x by x, it will be x times ln x negative 1. So I have multiplied this ln x by x. Now I can take this x as a common denominator over ln x the whole square. Okay, here we have a fraction numerator. In denominator also, if I have a fraction, it will be easier for me to do simplification. So I can assume this ln x whole square as a fraction by taking denominator 1. So e to the x power times x times ln x negative 1 over x. And now I'm going to change this division as multiplication. I take reciprocal for this one, then I'll be getting 1 over ln x the whole square. Okay, so when I multiply this one, this one, this one, I'm getting e to the x power times ln x negative 1 over. So when I multiply the two denominators, x times ln x whole square, it will be x times ln x the whole square. So this is the derivative of the given function with respect to x.